I know it's getting a little bit too much in this lecture, but anyways, we just continue and see how much you can take in. Okay, we're going back to the effect of wind friction. Okay, so you have wind blowing along the surface for a very, very long time, exceeding 1 day, and what you get in addition to the frictional force or the shear flow that you create is also the Coriolis force. And you could think of that situation like you have many thin layers stacked on top of each other, and each layer exposes a frictional force on the underlying or on the layer underneath. And because the Coriolis force influences the direction or operates on the direction of flows, you actually get something like a spiral type of shape of your horizontal current pattern. Okay, this is called the surface Ekman layer. And this is shown here for the northern hemisphere. In the southern hemisphere, it's a mirror image. So you have to put a mirror there and have a look at it looks like. So what you get under the influence of friction and the Coriolis force, you get currents where the surface currents are deflected 45 degrees to the right. Okay? And then the current veers to the right as you go deeper, and the speed decreases. So these arrows get shorter and shorter. And at some depth, there's even a reversal of the flow. Okay, it becomes very weak, but even the flow runs opposite to the surface flow. This is what we call the Ekman spiral and the surface Ekman layer. Yeah? You get these structures. Okay, in the southern hemisphere, you get a deflection 45 degrees to the left in the surface current. Okay, so now the most important aspect of that is looking at the net transport of water. Okay, and here are little sketches that show you the situation from the top. You have a wind direction, and you get the net movement of water is actually perpendicular 90 degrees with respect to the wind direction, 90 degrees to the right in the northern hemisphere, to the left in the southern hemisphere. And this is the important bit, because this feature you can explain how you get a convergence or a divergence. We talk about the details later on. So you don't need to know about the specifics of the spiral. Yeah? But you can see that there's a shear in this spiral. You also create turbulence and mixing in Ekman layers. But the other, the key feature is that the net transport, and there's an important rule you can see here in yellow. Okay. This one is that you should always remember, okay? Because you can explain the process of upwelling. Actually, if the current reaches the seafloor, only then you also get an Ekman layer near the seafloor. Okay, so the thickness of surface Ekman layers depends on the geographical latitude and depends on the that's the key feature. But it's typically 100 meters. Okay, near the seafloors, the Ekman layers are a little bit thinner. There's something like 20-30 meters, okay, and sometimes less. Okay, so this is another important feature now. It's the surface Ekman layer and Ekman layers developing near the seafloor.